Most people think we have a map of every threat in the solar system. But that map has massive, empty zones where our technology simply doesn't work. We've seen it from time to time again. Asteroids appearing out of nowhere, caught only by luck or amateur astronomers. Whether it's because they approach from the sun or they're made of material that absorbs all light, some of these rocks are impossible to predict. Now, the problem starts with something called the sky coverage gap. Most of our asteroid surveys rely on telescopes looking away from the sun. That means any rock approaching from the direction of sunlight is almost invisible until it's dangerously close. On top of that, asteroids aren't all reflective like the ones in textbooks. Some are dark, almost like black coal, making them nearly impossible to spot. But one thing astronomers often forget is their motion. Tiny forces like uneven heating from sunlight or gravitational tugs from other planets can push them off course in ways we can't easily calculate. If you combine this with the millions in our solar system, it becomes clear that we might know where most rocks are, but some are effectively ghosts. Because of these blind spots, some asteroids are only discovered hours before they pass Earth. In 2019, astronomers spotted an asteroid named 2019 OK just one day before it made a close flyby of our planet. It was nearly 100 meters wide, large enough to devastate a city, yet it had gone completely unnoticed until the last moment. And it's not the only time. In 2013, a much smaller asteroid entered Earth's atmosphere above Russia. The object exploded high in the sky with the energy of hundreds of thousands of tons of TNT, but astronomers never detected it beforehand. The asteroid had approached Earth from almost the exact direction of the sun, the very region where our telescopes struggle to see anything at all. But even when astronomers do detect an asteroid early, predicting where it will go isn't always straightforward. When a new asteroid is discovered, scientists usually have only a short window of observations. During that time, the object appears as a tiny moving dot against the background of stars. From those few points of light, they have to calculate an orbit that stretches millions of kilometers through space. That orbit can be extremely uncertain early on. A newly discovered asteroid might briefly appear to have a small chance of hitting Earth, only for that risk to disappear days later as more observations refine its path. As for other cases, the opposite can happen. An object that seemed harmless suddenly looks far more concerning once better measurements come in. One of the strangest forces acting on asteroids comes from something surprisingly ordinary: sunlight, as mentioned earlier. When sunlight hits the surface of an asteroid, it heats the rock just like the sun warms the ground on Earth. But unlike our planet, most asteroids slowly rotate in the vacuum of space, meaning one side heats up while another cools down. As the warm surface turns away from the sun, it releases that heat back into space as infrared radiation. The effect is far weaker than even the slightest push you could imagine. But in the frictionless environment of space, that tiny force can act continuously for years or even decades. Over time, it begins to work like a microscopic thruster, slowly nudging the asteroid into a slightly different orbit around the sun. Scientists call this the Yarkovsky effect, and it means that even if we calculate an asteroid's path perfectly today, its trajectory can gradually drift as sunlight itself pushes the rock off course. That may sound crazy, but what the planets themselves do is far more dramatic. As asteroids travel through the solar system, many of them occasionally pass near large planets, which causes the planet's gravity to pull on the asteroid and alter its trajectory. Sometimes only slightly, but sometimes enough to completely redirect its orbit around the sun. A rock that once circled safely within the asteroid belt can suddenly be pushed onto a new path that crosses the orbits of the inner planets, including Earth. Jupiter plays an especially powerful role in this process. Its immense gravity constantly stirs the asteroid belt, sending some objects inward toward the center of the solar system. And even with all of this complexity, there's another reason predicting asteroids is so difficult. We simply haven't found all of them. Astronomers estimate that there are millions of asteroids scattered throughout the solar system, and a significant number of them travel on paths that cross Earth's orbit. Large surveys over the past few decades have helped scientists discover many of the biggest ones, but smaller objects are still being found every year. In fact, thousands of new near-Earth asteroids are added to the catalog annually. Some of them have likely been passing through our cosmic neighborhood for millions of years without anyone noticing. Others may only appear briefly. Until they are detected, their orbits remain completely unknown, which means that in a lot of places out there, there are still asteroids we simply haven't seen yet. Some of those unseen objects are likely small, rocks only a few meters across that would burn up harmlessly in Earth's atmosphere. Astronomers believe that most of the truly massive asteroids have already been discovered, but smaller ones, capable of causing serious regional damage, may still be out there. Objects around 100 meters wide, sometimes called city killers, are particularly difficult to detect because they're small, dark, and easy to miss until they come relatively close. Because of this challenge, astronomers have begun developing new ways to search the sky more systematically. One of the most important ways scientists are improving asteroid detection is through new sky surveys designed to watch the heavens more systematically than ever before. Modern observatories now scan huge portions of the sky night after night, using automated systems that compare images and look for tiny points of light that move slightly between exposures. When the software detects something shifting against the background of stars, it flags the object for astronomers to investigate. These surveys have dramatically increased the number of asteroids discovered each year. Instead of relying on occasional observations, scientists can now monitor large areas of space continuously. And as these systems become more advanced, the chances of spotting potentially dangerous asteroids earlier continue to improve. Another promising tool comes from looking at asteroids in a completely different way, not by the light they reflect, but by the heat they give off. Infrared telescopes are designed to detect this faint thermal glow, allowing them to spot objects that appear almost invisible in normal visible light. This is especially useful for dark asteroids that absorb most of the sunlight hitting them. Though discovery alone isn't enough. In recent years, scientists have also begun testing ways to protect Earth if a dangerous asteroid is discovered early enough. In 2022, NASA's DART mission deliberately crashed a spacecraft into a small asteroid and successfully altered its orbit for the first time in history. The impact changed the asteroid's path slightly, proving that with enough warning, humanity may be able to push a hazardous object off course before it ever reaches Earth. Predicting every asteroid may never be possible, but with better telescopes, infrared surveys, and planetary defense missions, we're steadily improving our ability to track and monitor these objects. And the reality is simple. There will always be asteroids we haven't seen yet, and the best to do is to keep observing and preparing.